So, welcome all to Dr. MDS Academy. This animation presents a detailed visualization and explains how in composite wall heat conduction takes place. Here in the left side figure, you will find three different walls, one, two, and three walls having this length. Okay. So how the heat is taking place, heat transfer is taking place. Here resistance is something following, another R2 resistance is del2 upon K2 upon A. Here is another resistance existing RT3. Below is the live one example of composite wall. Okay. So in formula you will find Q is equal to change in temperature inlet minus outer wall temperature upon sum of the resistance. In animation you find TH is the hot, this one. So this is the 3D wall. Okay. So three different sections we are having. This is one. Okay. So L1 is what? L1 is like this. Okay. Up to this much length. L2 is this one. Middle one. And L3 is the last portion. This one. If we will increase the length of the L3, it is getting increased. Okay, so this is L1, this is L2, and this is L3. Okay, similarly K1, K2, K3 we are having. For these sections we are having thermal conductivity K1, K2, and K3, and T is the hot. Here hot temperature currently at 193 degrees Celsius, and another end is kept at T cold temperature, which is currently 27 degrees Celsius. Okay, so see here, as you are decreasing the hot, means this TH temperature, beginning temperature, first wall inlet temperature. Okay, as you are decreasing, see what is happening at the right top corner. You will find Q, heat transfer rate. Okay, in the below also you can find out real data you will be getting. The top one here R1 is the L1 upon K1 upon A. We know that here is another R2. For this resistance is what this value is, and R3 is the, for this the resistance is del upon K into A. Okay, here since all three walls are in series, so you can use this formula R1 plus R2 plus R3. So what is written over here R1 plus R2 R3. Okay, so and another one is T hot minus T cold is simply the change in temperature. Finally you will be getting Q is equal to change in temperature upon resistance according to this formula. Okay, according to these equations. So let's see, as you are decreasing the, as you are decreasing the T. Okay, what is happening? The Q is decreasing. Okay, so it is following the fundamental formula. As you are increasing the T hot, means at this wall temperature, hot temperature wall. Okay, so what is happening? Q is increasing. Okay, let's set the T value 153 degrees Celsius. Now let's change the T cold temperature. As you are decreasing the T cold temperature, means the right side wall temperature, cold temperature decreasing. So what is happening? The Q value is rising because the difference is getting more and more. As we are increasing the T cold, see what is happening? The difference is getting lesser. So Q is getting also lesser. Okay. So now similarly here A is what? A is this area. A is this area. So as we are increasing the A value, what is happening? The Q is increasing. Why it is happening? Q is directly proportional to A here. Q is Here Q is directly proportional to A. This. So more is the A value, more is the Q. So here more is the A value, more is the Q. See, Q is rising. Less is the A. As I am increasing the A value, the Q value is also getting decrease. Okay. So now L is what? L1 is this much length. For the first wall length, this length. Okay, this length. See here. This is K1, K2 and K3. Layer 1, layer 2 and layer 3. This one. So as you are decreasing the L value, what is happening? See, this length is decreasing. Okay, since what is the relation between Q and L here? See in the formula, Q and L. L1 here, instead of del 1 it is L1. So as you are decreasing the L, it is inversely proportional relations. What is happening as you are decreasing the L value? What is happening? It is getting increased because inversely proportional. So now let's increase the L value, L1 value. As you are increasing the L1 value, the Q value is getting decreased because of inversely proportional relationship. Similarly, you can check for the L2 also. Decrease the L2 value, see the Q value, current value. Okay, increase the L2 value, see the what is happening with K. It is getting decreased because of inversely proportional relation. Okay, similarly you can play with L3 also. Okay, so K1 is another. What is K1? K1 is the thermal conductivity of K1. So more is the K, more is the heat transfer takes place. Okay, because of what? Because of directly proportional relationship. Q is equal to what we know? Q is equal to K into A dt upon dx. So this is directly proportional. Okay, more is the K, more is the Q. So let's increase the K1 value. This thermal conductivity of this first layer we are increasing. So see, the Q value is in rising now, rising up. Okay, similarly you can play with K2 also. Similarly you can alter the value of K3 also. Just increase the K3 value. Okay, Q heat flow rate is increasing. Decrease the K value. Okay, Q value is decreasing. Okay, so this is what the different variables affect the heat flow rate. So by varying all these T, L and K for the different layers, you will be getting the different R1, R2, R3. This is R1, this is R2. Okay, resistance for the layer 2, resistance for the layer 3. Okay, since all these three are in series, so summation, simple summation will is valid. Okay, here. So let's check once more. Okay, below three different graphs are also there. Okay, Q versus thickness, Q versus conductivity means K, Q versus temperature difference. Okay, so let's change the hot tool. Okay, decreasing. See how the graphs are changing. Change in temperature has no effect on R. See, when you are changing the T temperature, okay, no effect in the R, resistance is taking place. Okay, similarly when you are changing the T cold, no effect on the resistance taking place. Why? Because temperature has no direct connection with resistance. Okay, as you are increasing the A value, see, all resistance are changing. Okay, all resistance are changing. What is resistance formula is R is equal to del upon K into A. Okay, similarly L1, L2 decrease, then rise. Okay, K1 decreasing, then increasing, K2 decreasing, then rising, K3 decreasing and then rising. This was all about the heat transfer, how takes place in the composite valve. So thank you all.